There is one warning about the build process. Before you build, your current directory must be in the same location as your Simulink model, like this. If you are not in the same directory as your model, when you try to build it, you will get this error. If you get this error, the first thing to check is that you are in the correct directory, which is where your Simulink model is. We will now create a new Simulink model for our host PC. First, we go to File, New and Model. A new Simulink model appears. This time, we don't need to configure our model to use the Rapid STM32 target because this model will be running on the host PC. So let's just save as ADC HID host PC demo and save. Next, we will open up the Simulink library browser, go to Rapid STM32 block set, add on modules, and find the HID receive block. We drag and drop it into our model. Now we can configure this block by double-clicking on it. Because we are receiving two single precision data types, we just type in single twice. Because we are sampling at a 100 Hz sampling rate, we just set the sample time to 10 milliseconds. Click OK and save that. Suppose we would like to convert the measured temperature in volts to Celsius, we just use Convert Onboard AN16 volts to Temp C from the on-chip peripherals block, here. Suppose we want to display this temperature as numerical values, we just go to the standard Simulink block and Sinks and drag this display in here. Suppose we want to plot the potentiometer voltage as a graph, we use the Scope block, again from the Simulink Sinks block set, and drag it here. Suppose we want to display the numerical display for the voltage as well. Instead of dragging the display from the library browser, there is a shortcut. We can click on display and drag the block with the right mouse button, and it will just copy the block. OK, so let's connect the signal line together like this. However, there is a special requirement for displaying the potentiometer voltage using the display block. This is because the display block requires an input of type double precision. As our potentiometer voltage is outputted as single type, we need to convert it from single precision to double precision type. We can do that by using the standard Simulink block. Go to Signal Attributes and Data Type Conversion. double-click on data type conversion and change the output data type to double. Click OK. To create another signal line from here, we just press the right mouse button, keep it pressed and drag it to the block. But here we can drag the signal line as normal. There is one useful tip about data types in Simulink, which is very basic and you should become familiar with. You can right-click on your model and select Format and Port Data Types. It will display all the data types that are being used in your model so that you can debug your model. Let's save this model for now. We cannot run it yet. We have to set our target to running mode first. So that is what we are going to do next. To put our target in running mode, all we need to do is change the program switch 1, to the left and press the reset button once. Now our target is running. If we go back to the simulation model for the host PC, update the model once, just ignore the warning for now, and press Run, you can see all the information displayed and a graph of the measured potentiometer voltage. However, this model will only run for 10 seconds, so if we want it to run for much longer, we can change it to infinity by typing in INF and then save. This model will run forever, so let's just see what happens. Click Run. If I adjust the potentiometer, you can see the changes in the voltage from 3.3 volts down to 0 and up again, like so. We can zoom into the graph by clicking on the binoculars icon, and I'll do that again. So this is it for our first program for acquiring real-time data into Simulink using the Rapid STM32 block set. Just a final remark about the performance specifications of the block set. At the moment, the maximum real-time data acquisition rate into Simulink and MATLAB is around 400 Hz, and it is possible to perform signal generation from Simulink to control the target and also to control hardware in a closed-loop simulation. Both settings have maximum update rates of about 200 Hz. These specifications are based on USB HID communication protocol. Faster speeds are possible. The hardware settings for both loop simulations will be the subject of our next training tutorial. For those of you who need further information, please visit www.imagine.com. There you can find data sheets for the FIO evaluation board and other information. Thank you for watching.